Hello and welcome. Our task for today is to find the value of this product x times y times z, given that x plus 1 over y is equal to 4, y plus 1 over z is equal to 1, and z plus 1 over x is equal to 7 over 3. As far as I know, there are two methods of solving this problem. The first method is to solve these three equations simultaneously. Get the value of x, get the value of y, get the value of z, and then multiply all three together to give us the product that we are looking for. But I think there's a more interesting way of solving this problem. You can see that we will get a term in x, y, z if we multiply all three equations. This is what I mean. We have x plus 1 over y multiplied by y plus 1 over z multiplied by z plus 1 over x. And of course, this must be equal to 4 times 1 times 7 over 3. And that is 28 over 3. Now, opening this bracket, we have x times y, which of course is equal to xy. We have x times 1 over z, which is x over z. We have 1 over y times y, which of course is equal to 1. And we have 1 over y times 1 over z, which is equal to 1 over y z. This is equal to 28 over 3. We continue with our multiplication. Here we have xy times z, which is equal to xyz. Next, we have xy times 1 over x. The x will cancel to leave us with y. Next, we have x over z times z. The z will cancel to leave us with x. We have x over z times 1 over x. The x will cancel to leave us with 1 over z. Next, we have 1 times z, and this is equal to z. We have 1 times 1 over x, and this is equal to 1 over x. We have 1 over yz times z. The z will cancel to leave us with 1 over y. And lastly, we have 1 over yz times 1 over x. And of course, we get 1 over x, y, z. And this is still equal to 28 over 3. Now, let us arrange this properly. So here we have x, y, z plus x plus y plus z. That is x plus y plus z plus 1 over x plus 1 over y plus 1 over z plus 1 over x plus 1 over y plus 1 over z. Then lastly, plus this plus 1 over x, y, z. And this is all equal to 28 over 3. The next thing we do is to add all three equations together. So we have x plus y plus z. So this is x plus y plus z. We have 1 over x plus 1 over y plus 1 over z. That is 1 over x plus 1 over y plus 1 over z. And this must be equal to 4 plus 1, which is 5, plus 7 over 3. That is 5 plus 7 over 3. Now, you can see that when we subtract the second equation from the first equation, all these terms will go to 0, leaving us with this x, y, z plus this 1 over x, y, z is equal to 28 over 3 minus. Now, when we add this to the LCM is 3. 3 divided by 1 is 3, multiplied by 5, 15, minus 3 divided by 3 is 1, multiplied by 7, 7. Sorry, this is plus. So we have 15 plus 7, and that is 22. So we have 22 over 3. From here, we have that x, y, z plus 1 over x, y, z is equal to 28 minus 22 is 6 over 3, which is equal to 2. And we have that x, y, z plus 1 over x, y, z is equal to 2. Now, by observation, you will see that the value of x, y, z that satisfies this equation is 1, because we know that 1 plus 1 over 1 is equal to 2. So we can safely say that the product of x, y, z is equal to 1. But if you want to be extra proper, you can say let x, y, z be equal to p for product. Then you have the equation p plus 1 over p is equal to 2. You can multiply through by p to get rid of this fraction. And when you do that, you have p squared plus 1 is equal to 2p. You have a quadratic equation, which you can rearrange to get p squared minus 2p plus 1 is equal to 0. Now we can factorize this equation because we know that the factors of 1 that will add up to minus 2 are minus 1 and minus 1. Because minus 1 times minus 1 will give us plus 1. And minus 1 plus minus 1 will give us minus 2. So from here we have that p minus 1 squared is equal to 0. P minus 1 is equal to 0 and p is equal to 1 twice, because a quadratic equation must have two roots even when the roots are coincident. So once more, we have found that the value of x, y, z is equal to 1. And that brings us to the end of today's exercise. I hope you learned something. I hope you were entertained. Remember to subscribe, like, and share. See you in the next one.